Welcome to Ask and Learn.
A sequence of potential differences V are applied across a wire, diameter 0.32 millimeters, length is 11 centimeters, and the resulting current I are measured as follows. So we're given this table here. If the wire obeys Ohm's law, graphing I versus V will result in a straight line plot. Explain why this is so and determine the theoretical predictions for the straight line slope and y-intercept. Plot I versus V. Based on this plot, can you conclude that the wire obeys Ohm's law, i.e. did you obtain a straight line with the expected y-intercept? If so, determine the wire's resistance R, calculate the wire's resistivity and use table to identify the solid material from which it is composed. Right, so we're going to begin from Ohm's law, which is given by V equals IR. So V equals IR. Now converting this into a straight line plot, so we're going to call this equation 1, Ohm's law equation 1. So equation 2, standard straight line equation, y equals mx plus c, where x is our dependent variable, x is our independent variable, and y is our dependent variable. And we're going to call this equation 2. And so we can see, in order to make equation 1 look like equation 2, we have to say that y is equal to v, x is equal to our current I, and that would make m equal to the resistance, and that would make c equal to 0. And so if our wire obeys Ohm's law, we expect to see an intercept of 0 and the slope to equal the resistivity. So in order to calculate the resistivity or the slope of the graph here, we are going to look at the change in voltage over the change in current. And this is equation 3 here. And from our table, we can see that change in voltage is equal to 0.4. And the change in current is equal to 360 minus 72 times 10 to the minus 3. So that gives us delta V is equal to 0.4 volts, and change in current is equal to 0.288 amps. And that gives us so M is equal to this, and so that gives us a resistivity of approximately 1.4. So it's 1.388 recurring, but we'll round that to 1.4. So, and that being said, moving on to part B of the question, which says that plot I versus V. Can you conclude that the wire obeys Ohm's law? If so, did you get that result? So here is our plot. So I've used Python to plot this out. Feel free to use your favorite programming language. And I've also extended the plot so that it extends down to 0 here. So that's what that component of the program is. So table of voltage, table of current. Using a standard function from SciPy Stats called a linear regress, which returns a list. The first two components are the slope and the y-intercept. We see that, so this would return a slope that needs to be factored by 1,000 because I haven't accounted in the question bit in typing this in. So this is milliamps, so that's why we've got multiplied by 1,000. And the results come out as a slope of 1.4, and the intercept is at 0. So yes, we can conclude that it satisfies Ohm's law of this wire. And finally, calculate the wire's resistivity and use table 1 to identify the solid material from which it is composed. So we're just going to start a quick new page from this one. So if we recall that we have resistivity, let's call that rho, is equal to pi. So the cross-sectional area divided by the length times the resistance of the material. So we have pi times, so we were told that the diameter is 3.2 millimeters. Let's just double check that. So 0.32 millimeters. So we can say that pi times cross-sectional area is pi times 1.6 times 10 to the minus 4, and square this. and divide through by the length, which is 0.11, and times by 1.4, which is the resistivity of the wire. So, and that gives us an answer of 1.0236 ohm meters as required. Perfect.